Happy day, YouTube. My name is John, and this is my channel, The Intermancer. On the last episode, I promised that I would be doing live coding going forward, and here we are. The very first thing I want to do is to clean up a little bit of mess over here in my organism domain objects context document. I mentioned this on the last video, but this endpoint for get organism repo list was fixed by the LLM to get to repo list or organism repo list just to list the IDs. That's the way I wanted to do it, but I hadn't been clear about that, but I had been inconsistent about that between my repository specification, where I specified organism IDs, and my endpoint specification, where I specified returning a list of organisms. So what I'm going to do is I'm going to make this endpoint consistent with the repo specification. Returns a list of all organism IDs in the repo repository. That's good. Okay. I have it to where the server runs, but it really doesn't do a whole lot. I can't see any organisms. I can't really put them in very well. So the first thing I'm going to do is fix that. And I've been thinking about how I want to do this. And the thing I think I need to do is to start a new context document about experimentation. So this will be default experiment life cycle. All right, for this other one, I started it with a little bit of intro text, so I'm going to do that here. Experiment life cycle. This document describes the classes and changes to existing classes to enable experimentation. Experiment life cycle. Okay, experimentation. All right, experiment life cycle is one part of it, not the whole thing. So I'm going to save it, save what I've got here, and I'm going to change its name. Rename. Rename. To just experimentation. So, why am I starting here? Because I realized that for me to just create some organisms so that I can just do the into and out of the repo, that's really the first part of the experiment life cycle, which is seeding the organism. So whenever you start you start an experiment in this genetic algorithm approach, you start with a set of either randomly generated organisms or seed organisms that were defined before. So I wanted to define some very basic seed organisms in this document. Over time, I will change what this looks like, but I realized that this was the appropriate place to start. So, seeding. Classes. Objects. And changes to existing objects. I know it makes me look like Winnie the Pooh the way I do weird capitalization. I don't know if it matters. I really don't. We'll see. So we will say that the first object is, do I want to talk about experiment life cycle and seeding as a phase in experiment life cycle, and then the objects? That's what I want to do. So what I'm going to do is I'm going to say this here. In seeding, I will say seeding is the first step in experimentation. A repository, an organism repository is initialized with a set of seed organisms. Objects. Okay. The root package for the base package, the package for the experimentation objects is com.intermancer dot extends from the root package of the project with experiment. Seeder. I know that I'm going to have different kinds of seeders eventually. So if you know you're going to have different kinds of things, then just start by declaring an interface for the most basic thing. The methods. Methods for this interface are interface. Concrete. Now see, if I was just thinking to myself, I would be bouncing back and forth with these ideas really quick. I'm trying to slow that down. I'm trying to do that out loud as I do it for you fine people. But I still do some bouncing. Concrete implementations of the seeder interface will have an organism repository auto-wired in. Again, I'm trying to get away a little bit from the Spring-specific syntax, but I still have some dependency injection concepts here. So we'll see how this plays out when it generates my code. Methods. How do I do methods again? Organism, domain, objects. Okay, just the backtick. Seed. Right now we'll see. I'm just going to say that the seed method. Oh, and over here, how did I have to do that? Put it on a new line so that it formatted itself well. The seed method of this seeder will load of a concrete seeder will load organisms into the injected organism repository. That's really all I need there. So now we will have a base seeder, basic seeder. The basic seeder is a very basic implementation of the seeder interface. It simply defines five. I'm just going to say 5. It simply defines 5 organisms, and it simply and statically defines 5 organisms and loads them into the repo. That all looks good. Here's another thing I learned the last time that I don't think I mentioned in the video is I realized that Claude will not just integrate with my GitHub repo, but I can point it to a particular branch in my GitHub repo. So right now I am in the JSON in and out branch. So I'm going to pop over here to Claude, go to my projects, go to Gaia F, and we're going to have to look at this. And instead of this create organism endpoint, we're going to have to delete this association and get. All you do is you grab the URL for the branch that you want to use and you give that to GitHub. So what I'm going to do here is I'm going to delete this bad boy. And over here, I am going to commit and push first changes to the context files for creating organisms and representing and using JSON to represent them in the through the endpoints. Okay, changes, add all of these changes, commit and push. Now I want to go back over here, check my code. I got 2 branches, active branches, JSON in and out. I have my Gen AI context. It has experimentation. Go back, all that's confirmed. Grab this URL, copy here, go back to Claude, in my project, add to the project knowledge, add to GitHub. it's letting me do this, but where do I do this? Use a link. Oh, it didn't grab the link. And now do you have it? There you have it. And take the source, and inside of here, take this experimentation and organism domain objects, take them all. I should have just added the directory and add files. It's doing all of that. So, as a looking at the current version of what I call it, experimentation .md, suggest 5 basic organisms to use in the basic seeder. Let's see what happens here. Thinking, very exciting, very exciting. Simple arithmetic organism, trigonometric analysis organism, data transformation organism. Okay, let's just read all this. I've been learning I need to pay more attention to reading. I'll probably fast forward through this on the video. Yes, here are 5 basic organisms. Simple arithmetic, chromosome 1, addition gene. This organism first adds 1.5 as to an input value that multiplies by 1.5, useful for demonstrating basic sequential gene operations. Trigonometric, sine multiplication. This organism applies sine function and then amplifies the result by 1.5. Demonstrates combination of trigonometric and arithmetic operations. Data transformation, addition, subtraction, multiplication, division. 2 parallel chromosomes, one for additive operations, another for multiplicative, shows how multiple chromosomes can process data differently. This one's interesting because ultimately it should have a net result of not doing anything to input data but adding new data channels. Sure. Reductive processing organism, division gene to subtractive gene to sine gene, a 3-gene chromosome that reduces values, normalizes, and applies trigonometry. And finally, basic composite organism, multiplication, additions. These organisms, okay, let's go with it. Let's do this. So I'm just going to grab these. I'm going to grab these, copy that, then over here in this seeder, I am going and load them into the repo. Organisms. Let's see. Okay, just cut and paste. Did this. We will have to do some formatting. 1, 2, 3, 4, 5. Boom. Let's go ahead and do that to all these. Okay. Let's see. Is that too much white space? A little too much white space. Artifact of copy paste from Claude. Get rid of this stuff. Okay. Let's do that. Change. All right. Now I'm going to push this up to the repo, getting everything out of Claude. And I'm not committed to getting everything out of Claude, but I'm doing that here. Anything that I want to get out of Claude, I've learned that the best way is to just push it up to the repo and pull it from there. Let's go ahead and do it that way. Yeah. Add that, stage commits, added the basic organisms as suggested. Suggested by Claude. Commit and push. There. Now come back over to Claude. Back in the project. Refresh this. Now remember, this definition is pulling that in experimentation context file. So once this is refreshed, which it has, I should be able to say, write the classes necessary to fully implement the basic seeder as described in experimentation.md. Experimentation. This is very exciting too. All of this stuff is exciting. So it's drafting it. Okay, the seeder is just an interface. That's fine. That's exactly what we wanted it to be. And the basic seeder pulls in all of those things. Auto wires in the repository. Oh, nice. It has the little methods. That's great. Organism, save organism. Gives it there. This is all great. It's doing everything as described. It's keeping all of the comments the way I want. It's telling me what it did over here. Let's just get eyes on all of these classes. Reading the code is important. Reading the code, having an active conversation with the LLM is very important for me to maintain some kind of basic awareness of what is going on in the project. Remember, one of my basic premises here is that if I turn over my thinking to the AI, then my brain will rot. So I can't let it just think for me. I have to read all of its output and make sure I agree with it insofar as I understand it. This method seed is just exactly what I asked it to do, since I took all of those basic organisms as it gave them in that previous chat. I should be able to see organism, new organism, gave it the ID based on the description. That's great. Set ID, multiplication. It's using all of the default values here. Excellent, excellent. I wanted everything simple, and it looks like it is all simple. So should be able to come here, and what does publish do? What will publish? What does the publish button do? When you click it, okay, I don't care about that. Here we go. Take this, copy this. Ooh, options. Copy to project. Download. Download as Java. Okay. This is going to force me, when I come back over here to my IDE, I am going to have to basically create my package. So alpha of core, I'll say new Java package experiment. There it is. There's nothing in it, and I will paste. Oh, did it not? Oh, did it download? Ah, it downloaded. Okay, So I should be able to import from my open and integrate a file, new folder, reveal in Finder, add Finder, new Java file. Okay, find in folder, open changes. All right, then we will just go to the file system. Codes, that's great. Why can't I shrink this? Whatever. Answer, code, Gaia F, source, main, Java, com, Intermancer, Gaia F, core, experiment, there's nothing there, and I'll put this, oh, but not name it that. We're just gonna say, let's see what this does. Ooh, open it. There it is. It looks like it compiled. Everything's happy. That is great. So now I will go to this basic seeder and I'm going to just copy this to my clipboard. And in here, I'll say new Java file, class, basic seeder, and I will paste what Claude gave me, save that. Genes, why is it telling me genes? Oh, genes is not publicly available. Look at that. This is not something I noticed when I was just reading code. See, that's one of the downsides of just reading code. I'm a person. I don't think in code. So I didn't notice that the chromosome it was pulling at, it just kind of hallucinated this genes property and didn't go through the basic getter and setter. So what I'll do is I'll say, there is no, let's see, an organism in chromosome, it sees genes, protected. Look at this. It didn't hallucinate. It told me that I had a place where I hadn't fully specified things enough, which is understandable. I hadn't actually run these things before. So this chromosome class has the protected genes, but that doesn't give me a way to access them. So what I need to do is over here in my context file where I describe chromosome, data quantum consumer chromosome has an ordered list of genes which the genes property is exposed using standard getter and setter methods. Okay. So, what do I want to do with this basic seeder? I'm going to go ahead and push it up, even though it has a compile error. I'm on a branch. I'm on a dev branch, so that should be okay. The changes I have is updated to this and added these two files. I'm going to stage all of these changes. Made some small changes added a first draft of Cedar and Basic Cedar, which exposed an error in the specification of chromosome. I updated the context document and pushing to GitHub so that Claude easily sees it, and commit and push. Okay. Even though I haven't gotten where I'm going, this is a good place to start because I'm trying to keep it around 30 minutes going forward. So I'm going to stop this video and almost immediately start another one so I can keep going. Thank you for your time.